Hello and welcome to Scholar Fedu. This is our UTME prep series where we provide relatively detailed solutions and explanations to the UTME questions. And in this recording, we are looking at the UTME questions for chemistry for the year 2016. This is the second part of the recording and the concluding part. We are going to look at the next 20 questions in that year. Alright, before we continue, please don't forget to subscribe to our channel, like and share our content. You can also visit our website at scholar.com to practice the UTME exam for free. First question: which of the following cannot be obtained by fractional distillation of petroleum? That is ether. Okay, ether is not obtained from the fractional distillation of crude oil or petroleum. Which of the following is used as an anti-knock in automobile engines? That is the lead tetraethyl. Okay, the lead tetraethyl. What we call an anti-knock are additive, okay, that are used to prevent engine failure. Okay, they are used to prevent the engine from knocking or failing. So it includes examples of such substances include the tetraethyl lead that we have here, or lead tetraethyl, toluene, isooctane, alcohol, and ferrocene. These substances are used as anti-knock agents. The Avogado number of 24 grams of magnesium is the same as that of. Now, the Avogado number is the number of particles in 1 mole of a substance, and that is 6.02 times 10 raised to power 23. Now, if you look at 24 grams of magnesium, 24 is the atomic mass of magnesium. So 24 grams of magnesium would mean 1 mole of magnesium. 1 mole of magnesium is going to have the same mass as 32 grams of oxygen molecule. Oxygen molecule is O2. Now, in that O2, the atomic mass of oxygen is 16. So in that O2, in that oxygen molecule, that diatomic oxygen molecule, the molar mass there is going to be 2 times 16, because there are 2 of oxygen in it. You have O2, there are 2 of oxygen in it. So that will be 2 times 16, that is 32 grams, and that will be 1 mole of oxygen molecule. So 24 grams of magnesium, which is 1 mole of magnesium, will contain the same number of particles as 1 mole of oxygen molecule, which is 32 grams. Next, in an electrolyte setup to protect iron from corrosion, the iron is. So this process is electroplating. Okay, we want to coat this iron with another metal. All right, and doing electrolysis, the iron that is to be electroplated, that is to be coated, is made the cathode. Okay, it is made the cathode. So the iron here that we want to electroplate is made the cathode. The removal of rust from iron by treatment with sulfuric acid is based on the reaction of acid and base. Okay, because the iron rust, the hydrated iron, is an amphoteric oxide. What that means is that it's an oxide that can act as a base and as an acid. So when you react it with an acid, it will be acting as a base. Okay, with an acid it will act as a base, with a base it will act as an acid. So reacting that iron rust here, the amphoteric oxide here, with the thiosulfate acid, is going to be, we are going to have like an acid base reaction here. So that iron rust is going to be acting as a base, and you have this as, an acid. So it's a case of acid base reaction. So it's like the reaction of an acid with a base. The substance often used for vulcanization of rubber is sulfur. Is used in the vulcanization of rubber. Okay, vulcanization of rubber is basically the addition of sulfur to rubber, okay, using zinc oxide, and the purpose of that is to further thicken the rubber, okay, to increase its strength while it still retains its elastic property, to make it stronger, okay, and thicker while it is still elastic. Metals of the first transition series have special properties which are different from those of group 1 and 2 elements because they have partially filled. Generally, the elements that you have in the transition series, they have partially filled d orbitals, okay, which accounts for many of the properties of this metal, like the formation of colored ions, their use as catalyst in some reaction, etc. A particle that contains 11 protons, 12 neutrons, and 10 electrons is probably A. Alright, let us work with the atomic number of the of that atom. The atom here in question has 11 protons, okay, meaning its atomic number is 11. Okay, it is 11. So if I write the electronic configuration, it is 281. Now the number of proton is equal to the number of electron. Alright, so this, as it has 11 protons, it's supposed to have 11 electron, but yet it is having 10 electron, meaning that it has donated 1 electron. Okay, it's supposed to have 11 electrons, it has donated 1 electron. So it is an ion now. It's going to be an ion. Okay, it will be an ion. But so which ion is it? Is it a metallic ion or a non-metallic ion? It cannot be neutral. Okay, it cannot be neutral because it has lost an electron. When an element, or an atom rather, when an atom loses an electron or it gains an electron, it will become charged. It will become an ion. An ion is a charged atom. It will not be neutral again. So these two, they are out. So we know that this is going to be an atom, an ion. But it's going to be a metallic ion or a non-metallic ion. Then we need to go back to this electronic configuration here. 281. This is the K element configuration. We look at the last number here. This last number here tells us the group to which the element belongs. And the last number here is 1, meaning that the element belongs to group 1. And group 1 elements are the alkali metals. They are metals. So we know that this atom is a metal. Okay, it is a metal, but it is not neutral because it has lost an electron. So that means it is a metallic ion. Okay, a positive ion, a cation. A catalyst increases the rate of a chemical reaction by providing a part that catalysts, they generally reduce or lower the activation energy. Okay, they lower the activation energy. The activation energy is the energy that is required for a reaction to occur, okay, to take place. So the catalyst, what it does is it will reduce that activation energy. It will allow that energy, that reaction to occur below the normal energy that it will require. Okay, it's like paying less to get the same thing that you get. That's how it is. So it helps to lower the activation energy, allowing for that reaction to proceed at lower than the normal, like not having with a lower energy. Okay, with an energy that is lower than what it will require. It would usually require. We have a website at scholar.com where you could practice exams for free, the UTME exam and the post-UTME exam. It also features modular quizzes in physics, chemistry, and biology. So if you've studied a topic in any of the subjects and you want to test your understanding of the topic, you can head on to our website at scholar.com and take modular quizzes for free. Also, if you sign up on the website, it has a personalized dashboard where you could use to check your progress in learning. We also have interactive sessions on the website and on our social media platform. Freebies are also available to top performance on the website. Next question here. A metal M displaces zinc from zinc chloride. This shows that the metal M is more electropositive than zinc. Okay, a more electropositive metal is going to displace another metal that is less electropositive compared to it. So that M displaces zinc from its solution means that metal M is more electropositive than zinc. Next question on electrochemistry. Calculate the quantity of electricity in coulombs required to liberate 10 grams of copper from a copper compound. We have the atomic mass of copper as 64 and 1 farad of electricity is 96,500 coulombs. Alright, the oxidation number of copper is +2. Okay, that means that to liberate 1 mole of copper, we are going to need 2 farad of electricity. 1 farad of electricity is 96,500. 2 farad is going to be 2 times 96,500 coulombs. So, and 1 mole of that copper, okay, to liberate 1 mole of copper, we need this amount of electricity. Alright, and that 1 mole of copper is equal to 64 grams. That is the atomic mass of copper that we have, or the molar mass of copper, we could say that. So we have 2 times 96,500 coulombs. That is, this amount of electricity will produce 64 grams of the copper. So the question is now, what amount will we need to produce 10 grams? So we say let the required quantity of electricity be what? X. That is 2 times 96,500 coulombs produce 64 grams bar. Now let's say X coulomb will now produce 10 grams. They will now set up a ratio between this side and this side, like between the left side of the equation and the right side. How do we do that? We simply say what you have on the left side here, 2 times 96,500 divided by what you have on the left side here, which is X, is equal to what you have on the right hand side, 64 divided by 10 on this right hand side here. Alright, so if we cross multiply, this 10 at the denominator here will multiply this, while this X that is at the denominator is going to multiply this 64 here. So that means we are going to have this multiplied by 10. So you have 2 times 96,500 times 10 is equal to 64 times X, and that's 64X. To get the value of X, we are going to divide both sides by 64. Now by the time we multiply all of these, 2 times 96,500 times 10, and we divide it by that 64, you'll be getting 30,156.25, which is approximately 30,156.3. So that means we require 30,156.3 coulombs of electricity to deposit 10 grams of the copper from a copper compound. That could be a solution of the copper, like a salt of the compound of the copper. The IUPAC names for the compounds CH3COH and CH2CH2 are respectively. So to answer this question, first we are going to look at what is the functional group that we have in this compound here. So if you look at this functional group here, is the COOH here, the carboxylic group here is a functional group, and this is the functional group in ethanoic acid. That means that this acid here is an alkanoic acid. Okay. Next, to determine which one is it ethanoic, is it methanoic, we will now look at the alkyl group that is attached to it. Okay. If it is H, that is methanoic. If it is CH3, that is ethanoic. If it is C2H5, that is propanoic, like that. And in this case it is CH3COOH. This is the molecular formula for ethanoic acid. Now for the second one, we can see you have a double bond here. That means that the element here, this compound here, alright, is an alkene. Okay, it is alkanes that have double bonds like this. They have others too that have double bonds, like even from the aromatic hydrocarbon, like the benzene. Okay, they have double bond, okay, between some of the carbon atoms there. But here, this is an aliphatic hydrocarbon, and this is alkene. Okay, so this is C2. This will be C2H4. C2H4 is the molecular formula for ethene. So that means here we have ethanoic acid and ethene. Next, the boiling point of water is higher than that of methanol because that is because of the intermolecular forces in water. Okay, the intermolecular forces in water are stronger than the intermolecular forces in methanol. Okay, so water is going to require greater heat, okay, for it to boil. Okay, an element X of atomic number Z and mass number Y is irradiated by an intense concentration of neutrons. The relevant nuclear equation is okay. Chemical equations, they follow the law of conservation of matter. Okay, the law of conservation of matter, which means that the sum of the atomic mass here must equal to the atomic mass that I have here. The sum of the atomic number here must equal to the atomic number that I have here. Now y plus 1 should be y plus 1, but here you have y minus 1, so this cannot be your answer. Y plus 1 here is y plus 1, z plus 0 is z. So this is a balanced equation, and this will be our correct answer here. Okay, this will be our correct answer. But if you look at the other options, we don't have that. Y plus 1, y, no. S plus, no. Y plus 1, y plus 1. This part is still correct. But if you look at the other part, z plus 0, we are now having z minus 1. That is not correct. Alright, which combination of the following statement is correct? Alright, 1, 2, and 3 are going to contribute to faster reaction. Lowering the activation energy, okay, will help to kickstart the reaction. Okay, also conducting the reaction in a gaseous state, because reaction of that is because of the intermolecular, the kinetic energy. That's a better, I think this is a better approach to it. The kinetic energy of the particles of a gas is greater than what you have in solids and liquids. Okay, so if you conduct a reaction, okay, if your solute, for example, could be a solid, could be a liquid, could be a gas, the best state you can conduct it is as a gas. Okay, because the reaction in gaseous state is faster than in any of the other states, in solid or as a liquid. Also, the third one, increasing temperature generally, because when you increase temperature of the reactant, what happens is you are increasing the kinetic energy of the particles in that medium. You are agitating them. Okay, so that would increase the rate of the reaction. All right, so all of that will contribute to a faster reaction. You can also join our online tutorial classes for different classes. We have tutorials for students in SS1, 2, or 3. We also have for UTME candidates, for JAMB candidates, for students who want to write the JAMB or the UTME exam, and for those who want to have the post-UTME exam after the UTME exam, and also for candidates that are sitting for WAEC exam or GCE or NECO. And we offer this tutorial on various platforms, so you could join us on WhatsApp or on Telegram, you could be on Zoom or on Google Classroom. So we have various platforms where we take our tutorial. The links to join the platform are available on our website at scholar.com, or you could also check it out in the video description below. An element with atomic number 12 is likely to be, alright, that element, we are going to write its electronic configuration. Okay, it has atomic number of 12, so that will be 282. So this element has 2 electrons in its outermost shell. Alright, this element would have, it has a greater tendency to form electrovalent compound by transferring these 2 valence electrons in order for it to attain octet structure, meaning so that it can be left with a shell that has 8 electrons. Okay, so it has a tendency to donate this electron. Okay, it has a greater tendency to donate this electron than to accept electron. So that means that this element is likely to form electrovalent bond, and it will have a valency, okay, of 2. Its oxidation number will be +2. Which of the following physical properties decrease across the periodic table? That is the atomic radius. Okay, the atomic radius. As we are going across the period, that's we are going from group 1 to group 2 to group 3. What is happening is that the number of valence electron, meaning the number of electrons in the outermost shell, they are increasing as we are going from group 1 to group 2 to group 3 across a period. Now, as more electrons are added, so more protons are also added, meaning more electrons on the shell, more protons in the nucleus. So there will now be a greater force of attraction, a greater pull between the protons and the electron. You know, the protons are positively charged, the electrons are negatively charged, and positive and negative charges, they attract, they pull each other. So there's going to be a greater pull as you go across the period between the protons in the nucleus and the electrons in the shell. So that will make the atoms kind of like shrink, and that would reduce its atomic radius across the periodic table. So the atomic radius is going to decrease. We have a question on gas laws. If a gas occupies a container of volume 146 cm cube at 18 degrees Celsius and is 0.971 atmol, its volume in cm cube at STP is. So this is a question involving volume, temperature, and pressure. Okay, so we will be using the general gas law here. All right, now let's look at the initial parameters that we have here. Excuse me. So yeah, the initial pressure. Okay, let me start from the order here. The initial volume V1 is 146 cm cube. The initial temperature is 18 degrees Celsius. We will convert that to Kelvin by adding 273, and that will be 291 Kelvin. While the initial pressure is 0.971 atmol. Okay, those are the initial parameters. Now we have to calculate its volume in centimeter cube at STP. At STP, the pressure is 1 atmol. Okay, at standard temperature and pressure, that's STP, the volume is 1 atmol, while the temperature is 273. Meaning, if the pressure becomes 1 atmol and the temperature becomes 273 Kelvin, what is going to be the volume? That is the new volume V2. So using our general gas law, we have P1 V1 over T1 equals P2 V2 over T2.
where what you have here are the initial parameters and these are the new parameters. To make V2 the subject of the formula here, we will bring this, we will cross multiply this T2 that's at the denominator here, we will take it to the numerator here, while we take the P2 that's at the numerator here, we'll bring it down to the denominator here. So we are going to have V2 to be equal to P1 V1 multiplied by T2 over P2 times the T1 that is already here. So we have our P1 V1 as this 0.971 times times V1, alright, times V1, which is 146, times T2, which is this one, 73, divided by P2, which is 1, times T1, which is 291. So by the time you multiply all of this and you divide it by 291, you'll be getting 132.9970. Approximately, that is 133 cm cube. 50 cm cube of carbon monoxide was exploded with 150 cm cube of air containing 20% oxygen by volume. Which of the reactants was in excess? Alright, so in this question, there's a reaction between carbon monoxide and oxygen here, okay, but we don't know we know already the volume of the carbon monoxide, but we don't know what is the volume of the oxygen that reacted with it. Alright, so we need to first find or calculate the volume of the oxygen that is reacting here. Now in this question, okay, we have it that the carbon monoxide reacted with was exploded with air, and that this air contains 20% oxygen by volume. So we need to know what is 20% of this volume of air is the oxygen. Okay, so the volume of oxygen here is going to be 20% of this volume of air here, 150 cm cube. 20% will mean 20 over 100, okay, and that is 0.2. So off, that is times 150, that will be 30 cm cube. So it means that 50 cm cube of carbon monoxide reacted with 30 cm cube of oxygen. Alright, now in order for us to determine which one was in excess, which of these reactants was in excess, we need to write the chemical equation for the reaction between the carbon monoxide and the oxygen, and here we have it. So we have 2 moles of carbon monoxide reacting with 1 mole of oxygen to form 2 moles of carbon dioxide. What does this mean is that whatever volume of oxygen we have, we need 2 times that volume for carbon monoxide. Okay, whatever volume of oxygen we have, we need 2 times of that volume for the carbon monoxide. That is the meaning. So or we can also say that whatever volume of carbon monoxide we have, we need half of it for oxygen. So you can say it either ways. Now if you are now using 50 cm cube of carbon monoxide, you are going to need half that volume for oxygen. That means you are going to need 25 cm cube of oxygen. I hope this is understood. If you are using 50 cm cube of carbon monoxide, carbon monoxide is 2 times that of oxygen. So the amount of oxygen that you need is half of that. So 50 cm cube of carbon monoxide will react with, according to what we have here, theoretically, it will react with 25 cm cube of oxygen. Okay, but in this case, the volume of oxygen that is used there is 30 cm cube. So that means that the oxygen is in excess. Okay, because what we need to actually react with this thing theoretically is 25 cm cube. Okay, but we have 30 cm cube, so the oxygen is in excess. Alright, the formula CH2O for ethylic acid is regarded as its empirical formula. Okay, the empirical formula shows the lowest ratio in which the atoms in the element is combined. Now the ethylic acid, this is the actual chemical formula for it. Okay, CH3COOH. If you look at here now, it has how many carbons? 2 carbons, 4 hydrogen and 2 oxygen. That means that the ratio of the carbon to hydrogen to oxygen there is what? Is 2, 4 and 2. We can divide through here by 2. So we are going to have 1:2:1. So you can say that the ratio of carbon to hydrogen to oxygen in it is 1:2:1. So we can represent this formula here. Okay, the empirical formula is going to be CH2O. Okay, CH2O, where for this ethylic acid, that N, okay, is equal to 2. Alright, the N. Now there's no N here. That's if I want to write the molecular formula for this compound now, I'll just say it is the empirical formula. This empirical formula here, CH2O. Then in bracket, I'll now put 1 N outside. Okay, that N means what I'm going to use to multiply these things here to get the actual number of atoms here. and that will be what we used to divide through here, which was 2. Okay, so if I multiply everything here by 2, I'm going to have C2H4O2. okay, C2 as in CC, H4, alright, 3 plus 1 here, then O2. That will be the molecular formula for the ethanoic acid. But this formula here, CH2O, where we have carbon to hydrogen to oxygen in 1:2:1, that is the empirical formula of the compound. Okay, don't forget to check out our playlist. We have different playlists. We have for full solutions to UTME or JAMB questions and in physics, chemistry and biology. We also have for modular quizzes as well. Okay, we'll also have a playlist for post UTME or post JAMB exam, and also for crash courses in physics, chemistry and biology. So don't forget to check out our playlist for the available videos. So that's it for this recording. Thank you very much for watching. Please don't forget to subscribe to our YouTube channel at ScholarFedu. Okay, like and share our content, and visit our website at scholar.com to practice UTM exam and modular quizzes for free. Thank you.